All right, Algebra 2, this is Unit 5.5. We're going to find roots, which are the same as zeros, solutions, x-intercepts. So remember all four terms, they all mean basically the same. You're going to factor it and then solve it. This should be the last unit for Unit 5. All right, and then after we find these roots, then we're going to also practice writing the equations, writing a function. So we kind of did this already in a previous unit. I think it was Unit 3. All right, so it says if a number h, so we have some number, is a root, which is same as 0, solution, x-intercept, to a polynomial. So if h is a root to a polynomial, then the factor x minus h, okay, so we have this binomial x minus h is also going to be a factor to the polynomial. All right, so if h is a 0, then the factor x minus h is the factor. All right, so for example, we put a number in there. If we know that -8 is a 0 or an x-intercept or a solution, then its factor is x plus 8. All right, so x plus 8 is called the factor if -8 is a 0 or a solution. Also, if 6 is a 0 or a solution or an x-intercept or a root, then its factor is x minus 6. So you can see when we know what the 0 is, to get the factor, we just change the sign. And we did this the opposite. When we had the factor and we want to find x-intercepts, we just change the sign. Or you set the factor equal to 0 and solve for x. All right, and so that's basically what we're doing. If we know that -8 is a 0, that means that x equals -8. All right, and then if we want to turn it into a factor, we're just bringing it over to the side that has the x. And so we have x plus 8. All right, and so there's our factor if we know that 0 or -8 is a 0. All right, so that's why it changes signs. All right, so let's go ahead and do this polynomial. Given the function x squared plus 3x minus 8, let's list the factors and the zeros and the roots. All right, so because this is just a quadratic, it's a trinomial, we could try to factor it. And if it didn't factor, then we could use another method using quadratic formula. All right, but this probably factors, so let's see. We would use the x method. All right, so two numbers that multiply to -18 but add to 3, it's going to be +6 and -3. So +6, -3. And so that means the factors are x plus 6 and x minus 3. The zeros are -6 and +3. The roots, same as zeros, -6 and +3. All right. Also, the degree of a polynomial, remember, is equal to the total number of zeros or solutions that we're looking for. They can both be real and imaginary. So always look at the degree of the polynomial. That's going to tell you how many total solutions you're looking for. All right, so let's go ahead and do this example. If x minus 10 is a factor, to this polynomial, find all the zeros. All right, so what we want to do is use this factor, and we're going to use synthetic division, and we're going to factor it, and then we're going to solve it to get the zeros. So since the factor is x minus 10, using synthetic division, we would change the sign. So we use +10. All right, so the coefficients, 1, -12, +12, and 80. All right, so we bring down the first term, and we multiply, add down, just keep it going. Now, if you do this correctly, you should always get 0 in the remainder. All right, and because 0 is the remainder, that means that 10 is a 0, and it's x minus 10 is the factor. All right, so now we can turn this into a polynomial using 1, -2, and -8 as the coefficients for your new polynomial. So this would be x to the second power minus 2x minus 8. Remember, look at the original degree and drop your answer by 1 degree, and then just continue to drop it down 1 each time. All right, so we have x squared minus 2x minus 8. So we want to try to factor this. So -8 would be on top, -2 is on the bottom. That would be -4 and +2. So this does factor into x minus 4 and x plus 2. All right. And so the question says find all the zeros. All right. So we want all the solutions. And since this is a degree 3 polynomial, there's 3 solutions that we want to list out. All right. And so we have from x minus 4, we have +4. From x plus 2, we have -2. And then from that x minus 10 factor that they gave us, we have +10. All right, so there's your 3 zeros, or solutions. All right, example 2. 1 is a 0 to this polynomial, find all the zeros. All right, since they're telling us that 1 is a 0 or a solution to the problem, using synthetic division, we don't change the sign. All right, so remember, we only change the sign if they give it to us as a factor. So since 1 is the 0, we use 1. All right, and so again, because it's saying that 1 is a 0, when you do the synthetic division, you should get a remainder of 0. All right, so 4, -4, -9, and +9. All right, bring down the first term, multiply, add down, multiply, add down, multiply, and add down. All right, so we have a remainder 0. All right, so now we'll write our new polynomial. Again, the original polynomial started with 4x to the third, so our polynomial, 4x squared. Then it'd be plus 0x, but we're going to not put that in there because it's a 0x, and then minus 9. All right, and now we want to go ahead and solve this. 4x squared minus 9 is a binomial, and so we could recognize that this is a difference of 2 squares, and so it's going to factor with a plus and a minus. And because we can square root both terms, it becomes 2x plus 3 and 2x minus 3. All right, and again, they want the zeros, not the factors. And so we set each factor equal to 0 and solve for x. Again, you can set 2x plus 3 equal to 0, 2x minus 3 equal to 0, and solve. All right, and so if you do that, you're going to get -3 over 2, positive 3 over 2, and then also you're going to get that positive 1 that they gave you. Okay. Now, on this problem, 4x squared minus 9, since they're just asking us to find the solutions, you don't have to necessarily list out the factors, there is another way that you could solve 4x squared minus 9. You could just set it equal to 0 and solve it using square roots, the square root method. All right, not square rooting both numbers, you're using the square root method. And so if you remember this method from Unit 3, we would isolate the x squared term. Well, to do that, we would add the 9 over first, then divide by 4, all right, and then we would square root, all right, and we have to put plus or minus in front. All right, now we have the plus or minus the square root of 9/4. All right, and we have to simplify that. Well, you can't leave a fraction inside a radical, so you can split it up into root 9 over root 4, and that's 3 over 2, with that plus or minus in front. Okay, so plus or minus 3 over 2, and that's the same thing that we got, but we used the factoring method instead. So it's up to you which method you want to use. You know, obviously, if it said list the factors, then we have to give the factors. But if it says give the solutions, then you can find the solutions in any method that you want. All right, so let's do example 3. -3 is a root to this polynomial. Find all the roots. All right, so remember, roots are the same as solutions or zeros. So we're going to do it basically the same that we did for number 2. We don't change the sign, so we keep it at -3. All right, the coefficients are 1. Now, we don't have an x squared in this, so we're going to put a 0 as the placeholder, then -13 and -12. All right, so let's go ahead and finish this synthetic division. All right, got the remainder of 0. So let's go ahead and write the polynomial. So this is x squared minus 3x minus 4. And let's go ahead and use our x method for factoring. Right, so two numbers that multiply to -4 but add to -3, -4 and +1. Right, so our factors are x minus 4, x plus 1. All right, so the question says find all the roots or zeros. All right, so we just set those equal to 0 and solve it. And then we're going to get +4, -1, and then the root that they gave us, we want to list that also, -3. All right, writing polynomial functions or equations. All right, so given the following graph, write the polynomial function in both factored form and standard form. All right, so first question says, what are the zeros? So the zeros, again, are the x-intercepts, and so we can see -1 and +2. Now, -1, because of the bounce that's occurring, -1 has a multiplicity of 2. Right, and so there's a double -1. So there's two -1s that are occurring. That's how you get the bounce. Okay, and then you have the +2. This is a degree 3. Again, you could count the slants, 1, 2, 3. And we could also, on this problem, you could see that the degree of this polynomial 3 is also going to equal the number of zeros there are. Right, so you have the 2 zeros that are occurring for the -1 because of the bounce, and then you have 1 for the 2. And again, you'll see it when you write the factors. Okay, so in factored form, you can use y equals or f of x equals. That -1, to write it as a factor, you change the sign, so it's x plus 1. And because there's a bounce, we need to put a square on it. All right, so that occurs twice. And then we have that 2, so that factor would be x minus 2. And again, if you count up all the x's in this factored form, you can see it's 3, and that's the same as what the degree is. We can see that the right arrow is pointing up and the left arrow is pointing down, and that means that the coefficient, the leading coefficient, is positive. Now, it doesn't matter for this purpose what number's in front. We just want to make sure it's a positive number. So you can just leave it the way it is. It just says that leading coefficient is +1. But let's say it was flipped, then you would put a negative in front, and that means that the leading coefficient is some negative number like -1. All right, now we want to go ahead and write this in standard form. That means we're going to multiply this out. And so this is from Unit 3 when we multiplied binomials together. All right, so here is the factored form. So now to turn this into standard form, I'm going to go ahead and write this out twice. And then the x minus 2. And now we're going to go ahead and take two of them and multiply them together. So you can use the box method. You can double distribute, FOIL, so whichever method you want to use. All right, so it's x squared plus x plus x plus 1. Combining like terms, x squared plus 2x plus 1. I'm going to take that and multiply it by x minus 2. Okay, again, we'll multiply this out, combine like terms. All right, so taking x squared, that'd be x cubed minus 2x squared. Okay, take the 2x now and distribute, plus 2x squared minus 4x. Okay, now take the 1 and distribute, plus x minus 2. All right, so let's combine like terms now. X cubed, negative 2x squared plus 2x squared is 0. That cancels out. Negative 4x plus x is minus 3x, and then minus 2. All right, so here's standard form. Again, you can see in standard form the degree is 3, and that's what our degree is. All right, so let's go ahead and write the polynomial function in factored and standard form, given the following zeros. All right, so we have a 0 at 0, -3, and +4. So there's 3 of them. So that means our answer is going to be a degree 3 polynomial. So the factored form, so we have x minus 0. X minus 0 is the same as just x. Negative 3 produces the factor x plus 3, and then positive 4 produces the factor x minus 4. Again, just change the signs. All right, and now we're going to multiply this out. Okay, so again, this is our factored form answer, and now we can get the standard form. Again, just take 2 at a time, multiply them together. So I'll just take the first 2, distribute the x in, x squared plus 3x. I'm going to take that and multiply it to x minus 4. Again, the order doesn't matter. You can take x plus 3 and x minus 4, multiply those together, and then distribute the x in. All right, so multiplying these together, I'm going to get x to the third minus 4x squared plus 3x squared minus 12x. Combining like terms, x cubed minus x squared minus 12x. Y equals in front. All right, number 2. Okay, our zeros are at 7, has a multiplicity of 2, and then negative 5. So that means 7 is being repeated twice. So that means the factored form would be x minus 7 squared, or x minus 7, and then x plus 5. All right, again, this is a degree 3 polynomial. And so in standard form, we should have a degree 3 polynomial as our highest exponent. All right, so let's go ahead and take x minus 7. We're going to write it twice. We're going to double distribute. Combine like terms. Okay, and now we'll bring down that x plus 5, and we'll multiply those out. All right, so 49 times 5, let's see, 245. All right, so combining like terms and putting this in standard form, let's see, I'll put the answer right here. So x to the third, 5x squared minus 14x squared is minus 9, x squared. Negative 70 plus 49 is negative 21. X plus 245. All right, number 3, the zeros are at negative 2i and positive 2i. All right, so when you have imaginary zeros or radicals, you can write the factored form in 2 different ways. You can write them as linear factors, or you could actually multiply them out and you'd have a quadratic factor. So let me show you what this looks like. All right, so the linear factors, so if negative 2i is a 0, its linear factor would be x plus 2i. Linear means it's x to the first power as the factor. Okay, and then 2i produces the factor x minus 2i. All right, so that's fine. You could leave it like that in factored form. You could also multiply those 2 out and write it as a factor. So it's going to be up to you because you're going to be multiplying these 2 together anyway. This is fine the way it is for factored form. All right, now standard form, we're going to go ahead and double distribute and multiply this out. So this is going to be x squared minus 2ix, or 2xi, it doesn't matter. All right, and then we'll distribute the 2i over. So it's plus 2ix, or 2xi, minus 4i squared. All right, now negative 2ix plus 2ix is 0. They cancel out. And then minus 4i squared is really plus 4. All right, so we really have this polynomial x squared plus 4. All right, again, you can see this is a degree 2 polynomial. We have 2 factors, so that's degree 2. And there's 2 zeros that were given to us, and that means it's degree 2 also. All right, and last one, number 4. Our zeros are at 1, negative root 3, and positive root 3. Again, this has 3 zeros, so our degree is going to be degree 3. Factored form would be x minus 1, x plus root 3, x minus root 3. All right, so that's fine just like that. Those are linear factors. Then we're going to go ahead and multiply these together. Now, what I would do anytime you have imaginary or radicals as zeros, multiply those two together first. And if you do it correctly, all your radicals or imaginary, the i's will cancel out. Okay, so like on number 4, again, you could do this in any order. You could multiply the x minus 1 and the x plus root 3 together first, but you're going to have to deal with radicals, and it makes it a little bit more difficult. So take the 2 radical factors and multiply those together first, and the radicals should cancel out. All right, so let's go ahead and take these 2 first. All right, so double distributing, that's going to give us x squared minus x root 3 plus x root 3 minus root 9. Okay, so root 3 times negative root 3 is negative root 9. Now, if we simplify this, we get x squared, the middle terms cancel out, and then we get minus 3. Radical 9 is 3. All right, so we get this binomial x squared minus 3 when we multiply x plus root 3 times x minus root 3. Now we're going to go ahead and bring down this x minus 1, and we'll multiply those 2 together. All right, so that's going to get us x cubed minus 3x minus x squared plus 3. All right, so writing this in standard form, decreasing order. Oh wait, this was x cubed. X times x squared was x cubed. Let me fix that real quick. There we go. All right, so writing this in descending order, x cubed minus x squared minus 3x plus 3. So there's no like terms that we can combine in this problem. All right, again, you can see that our polynomial is degree 3, factored form, degree 3, and zeros. There's 3 zeros, so they all match. All right, and that is it.